convert decimals to fractions. Now the first one we're going to look at is 0.0175. Here's the first step. You count the number of figures after the decimal point. I've got 1, 2, 3, 4. So my denominator is going to have 4 zeros. So the bottom number is going to have 4 zeros. So I write that as 175 over 10,000. Why did I miss out these other figures? We just write the string of significant figures. Okay, now the next step is, can I cancel it down? Let's look at common factors. This ends in 0, that ends in 5, so I can. Now here's a quick way of dividing both top and bottom by 5. 25 might go in, or 5 might go in, I don't know. But here's the quick way of dividing by 5. Cover up the last figure, and then double what you have left. Okay? So, double 17 is 34. There's one other rule. You don't just double up the other two. If you covered up the 5, you add 1. So, 175 divided by 5 is 34 add 1, 35. And 10,000 divided by 5 is double that, 2,000. Can I cancel it again? Yes, I can. So, probably the cleverer ones here might have been able to divide by 25. So, here we go. And just proving that the rule about dividing by 5, cover that up. 3 doubled is 6, add 1 because you covered up a 5, so it's 7. And then I'm going to double this, so it's 7 over 400. There you go. That's 0.0175, questions at the end. Turned into a fraction in the simplest form, questions at the end. Now, here is where it gets tricky. 0.13 recurring. How do I turn that into a fraction? This is what you do. We're going to introduce a bit of algebra to help us. We're going to let x equal 0.13, 13 recurring. Do you see how we use the other longer notation for recurring numbers? I had 2 figures recurring. So what I'm going to do is I'm going to work out what 100x is. Now when you multiply by 10 or 100 or 1,000 and you've got decimals, it's easy. You just move the decimal point the same number of places as the zeros. So 100x is 13.13. 13 recurring. And this is the elegance of this. Watch what I do to get rid of all these infinite string of 13s. I'm going to take this away from that. 100x, take away x is 99x. And then, what do we get here? Well, let's work from the right. The 13 and 13, they cancel each other out until all we're left with is it's 13, take away 0, which is 13. And then, can you see, anybody guess what we're going to do next? If 99x is equal to 13, x equals 13 over 99. Right, let's go through that once more. Example 3. What is 0.315 recurring as a fraction in its simplest form? So our first step is going to be, we're going to let x equal 0.315, 315, and so on. Anybody guess what I multiply by? Do I multiply by 10, 100, or some other number in this instance? Yes, young man?
5.
No, not by 5. Boy at the front. Yeah. Good. Yeah. It had 3 figures that kept recurring, so I multiplied by a number that has 3 zeros after 1, which is 1,000. So we get, I think I've jammed myself up here a little bit, bless you. Just going to move those to the... So 1,000x is, again, there's no real arithmetic. It's going to be 315.315, 315 recurring. And now when I take them away, 1,000x take away 1x, or x, is 999x. And look at the beauty, the elegance of this mathematical solution to a problem. These groups of 315s after the decimal point, they all cancel each other out. And we're left with 315 take away 0, which is 315. So x is equal to 315 all over 999. But you're not quite finished. Questions at the end, I said. Actually, if you look, this number here and this number here can be divided by 3. That's obviously, I think you can see that can be divided by 3. But so can the top one. And remember, the little rule for that is add the digits together. 3, add 1, add 5. If what you get when you add the digits together is a multiple of 3, then you can divide by 3. So I'm going to divide the top by 3 to get 105 over 3, 3, 3. Can I divide it even further? Well, I can't divide by 5, but can I divide by 3 again? So hang on. 1 add 0 add 5 is 6. Yep, that's a multiple of 3. It's in the 3 times table. So I'm going to divide again by 3 to get 35 over 1, 1, 1. And there you go. In some ways, the hardest bit was simplifying the fraction.